So our first sample problem kind of went through the first basic skill that we need for electrochemistry, which is understanding how to balance redox reactions. Our second problem here begins working through voltaic cells, in particular thinking about how to diagram voltaic cells. Again, looking at kind of a blank voltaic cell like this, be able to take information that's provided and kind of fill in so that we understand what things go in which compartments. So here is our sample problem here. It says draw a diagram, show balanced equations, and then write the notation. And I'm going to go through how to write the notation, but we didn't go through that very thoroughly in class. But we will learn how to write the notation for a voltaic cell that consists of one half cell that has a chromium bar in a chromium nitrate solution, and another half cell that has a silver bar in a silver nitrate solution, and then there's a potassium nitrate salt bridge. Measurement tells us that the chromium electrode is negative relative to the silver electrode. So all of the information that we need to have there is written in this little paragraph here. And something that's really important here is that they tell us that the chromium electrode is negative. And one of the things that we have to remember is our little acronym, or I guess it's not an acronym, a little saying that said anox and then a red cat. And that reminds us that the anode is where oxidation occurs and reduction is where the cathode, reduction occurs at the cathode. And again, if you see this little T in cathode, that reminds us that the cathode is positive. So the chromium electrode is negative. So that means that the chromium electrode is our anode. Another thing that you just kind of have to remember with diagramming voltaic cells is that the anode, by convention, is always drawn on the left, and then the cathode is on the right. And again, there's our little plus sign in our cathode to remind us that the cathode is positive, the anode is negative. And when we remember an ox and a red cat, that tells us that the anode is where oxidation occurs, and the cathode is where reduction occurs. So they told us that the anode is where the chromium electrode is. So this again is our electrode here. So that is going to be a chromium bar, which means that there's chromium 3+ ions in solution. So that must mean over here, this is our silver bar. And then we've got silver ions in solution. We've got potassium and nitrate ions that are up here, and in a moment we'll think about this again as our salt bridge here. We'll talk about which direction these are going to go. By formalism, if the anode is where oxidation occurs, which is where electrons are generated, electrons are going to flow through our wire to the cathode where reduction occurs. So oxidation, again, we're going to have our chromium 3+ half cell, and then we've got our silver plus half cell over here. So for the most part, we've diagrammed what we need here for our voltaic cell. We still need to think about where our ions are going from our salt bridge. We'll work that out in just a minute here. But we need to write balanced equations for what happens in each half cell. So anode, again, is where oxidation occurs, which tells me that this is the reaction that occurs. Our chromium electrode is going to be breaking down and losing mass because we're generating chromium ions in solution. So we're going to see an increase in the chromium ion solution here, and this electrode is going to lose mass. And here's the chemistry for what happens. It's an oxidation reaction of chromium. If we think about the same for silver here, and knowing that reduction occurs at the cathode, that means this is the chemistry that's happening with silver. So our silver ions are going to be depleted. So we're going to be decreasing our silver ion concentration, and this electrode is going to gain mass. Again, those are all kinds of questions I can ask you in terms of qualitative stuff about voltaic cells. Which electrode would lose mass? Which ion is going to increase or decrease in concentration? If we go ahead and write a balanced electrochemical equation here, a redox reaction, 3 electrons being lost means we have to scale this up by 3-fold. So we're going to have 3 Ag plus 3 electrons going to 3 silver. Combining these together for our full reaction, chromium solid plus 3 Ag ions goes to chromium 3+ ions plus silver solid. So again, that's the overall balanced redox reaction. And to write this with notation, one of the things we have to remember with notation is we're going to use double lines that will indicate the difference between anode compartments or anode components and cathode components. So we can even kind of write that right below here to say here's the dividing line between our anode and cathode compartments. So in our anode compartment, we're going to have a solid chromium electrode. We use single bars to indicate phase changes, and we've got chromium 3+ ions. On the other side, we've got silver ions and then phase change with our solid silver electrode. Now, if there was more than one ion in solution here, we'd use commas to separate those, and we'd keep them between the same bars here. Okay, the last little piece that we didn't kind of diagram on our voltaic cell here was thinking about which way ions are going to move in our salt bridge. So if you want, you can just memorize that negative charges go to the anode, but I think it's easier if you just understand why, and that way you don't need to memorize it. Remember, we talked about here that the chromium ion concentration is going to be increasing, which means we're increasing the positive charge in this compartment. So to kind of counteract that, we need anions, or the nitrate ions, to flow this way in our salt bridge. Similarly, we're depleting the positive charges in our cathode compartment because we're taking those silver ions and reducing them to silver solid. So in that case, we need to have our potassium ions, our positive charge, move towards the cathode. So all of that information kind of represents the summation of skill number 2 in this chapter, which is understanding how to diagram a voltaic cell, thinking about the notation that we have here and all of the qualitative aspects that come with that, thinking about what electrodes, if any, would lose mass, what concentrations of ions are going to be increasing or decreasing, which way species are going to migrate through our salt bridge.